Okay, restaurant, let's see what is there in this question. A single loop of wire of resistance 10 ohm has its plane perpendicular to the changing magnetic field. The graph shows the variation with time of the magnetic flux through the loop wire. So the flux is definitely directly given, like it is Weber, and the unit here is second. What is the maximum current in the loop? Okay, so according to the question, there is only one loop. It means like that n is equal to 1. There is only one loop, and magnetic field is passing through it like this. Yes. So there is a certain value of a flux, and the graph is given because it is having a variable magnetic field every time. So, as a matter of fact, or just for the remembrance, I can tell you flux formula is given by B A cos theta, where B is the magnetic flux density. You can call it magnetic field strength also. And A is the area which is perpendicular to the magnetic field, and theta is the angle between the two variables, that is area and the magnetic field. So whenever there is a variation in the flux with respect to time, EMF is generated. So EMF is given by delta phi by delta t. Now flux can vary, point number one, with the help of magnetic field, which is actually the case here. Point number two, with the help of the area of the loop, which becomes the case of motional EMF. And theta, which is kind of orientation, which is exactly the case with the electric generators. Okay, having said that, we are not going to move into the 100% details now. Okay, so the graph given is flux and time. So flux and the time graph is given. We want to find the maximum current in the loop. So the current will be a variable and we have to find the maximum value. So at this point, the flux is variable for the first 2 seconds, and from 2 second to 5 second, flux is not a variable. So when flux is not a variable, EMF is not produced. So in this case, EMF is not produced, but here EMF is produced. Here EMF is produced in both of the cases. But here we can clearly see that the slope is more. So d phi by dt or delta phi by delta t, which is actually the slope of phi t curve. So the slope of phi t curve is more in this case and lesser in this. The slope is lesser. So the EMF produced here will be, we have to find the tangent theta here, okay? So that will be 40 Weber divided by 20. So it will be 40 divided by 2, that is 20. So this is d phi by dt, so that is the EMF. So EMF generated in this case initially is 20 volt and the resistance given is 10. Clearly the current produced will be 20 divided by 10, that is 2 amperes or 2 amps. So the answer will be B. But let us first verify from the other side also, because like it is clearly, we can clearly judge it from the diagram that this slope is more than this. Definitely more EMF will be generated in first 2 seconds, and that is why the answer will be 2. But let us go for this EMF now. Yeah. So the answer for this is, let us see, 40 divided by 1, 2, 3, 4. So it is 40 divided by 4 seconds. So that is 10 volt. Clearly, the EMF is 10, and so the current produced now is 1 ampere. So our answer is 2 ampere for this question. So this is how we do this question, dear students. This is Professor Varun. Thanks for joining. All the best.